What is a one-to-one function? Let's dive into this fascinating concept in mathematics. A one-to-one function, also known as an injective function, is a special type of function where each element in the domain maps to a unique element in the range. To put it in simpler terms, no two different inputs can produce the same output. Let's illustrate this with an example. Consider the square root function f(x) equals sine x. This function is one-to-one, as for any two distinct inputs x and y, their square roots x and y will also be distinct. Another example is the identity function f(x) equals sine x. Here, for any two distinct inputs x and y, the outputs are also distinct, which are x and y respectively. The exponential function f(x) equals sine x also falls into the category of one-to-one functions. For any two distinct inputs x and y, their exponentials x and I are also distinct. While these functions are one-to-one, not all functions share this property. Take, for instance, the function f(x) equals sine x squared. This function is not one-to-one, as for x equals sine 2 and x equals sine minus 2. Their outputs f2 equals sine 4 and f minus 2 equals sine 4 are the same. Similarly, the function f(x) equals sine sin x is not one-to-one. For x equals sine p3 and x equals sine 2p3, their outputs f p3 equals sine sin p3 and f 2p3 equals sine sin 2p3 are both equal to 3, 2. Another example is the function f(x) equals sine x. This function is not one-to-one either, as for x equals sine 2 and x equals sine minus 2, their outputs f2 equals sine 2 equals sine 2 and f minus 2 equals sine minus 2 equals sine 2 are the same. One-to-one functions hold a special place in mathematics, as they can be used to define inverse functions. An inverse function essentially reverses the operation of another function. The inverse of the square root function is the squaring function, and the inverse of the exponential function is the logarithmic function. So remember, a function is one-to-one if each element in the domain maps to a unique element in the range. This means that no two different inputs will yield the same output. This property makes these functions key in defining inverse functions. So the next time you come across a function, take a moment to determine if it's one-to-one. It's a simple concept, but it's at the heart of many mathematical operations.